find 30% of 550, what we want to do again is to set up our percentage ratio. And 550 is going to be the whole. So we have our decimal multiplier of 0.3. And so 550 times 0.3 gives us 165. So x is equal to 165. So 165 out of 550 is the same as 30%. Now this one as a multiplier, we start with 550. 30% we can just multiply by 0.3, and that gives us our 165. And we can see that in our multiplier here. So 550 times our multiplier 0.3 gives us the value that we're looking for, which is 165. For the sale, here we have shirts that were sold for $15 each. This price is 80% of the original price. What's the original price? So setting up my proportion, 80% out of 100. I have to decide, is the $15 part or the whole? So in this case, $15 represents the sale price, so the whole here is my unknown. When I divide, I get my decimal multiplier. That decimal multiplier is a unit rate, which is our decimal percentage. I'm going to use that in the opposite direction. So I'm going to divide. So again, this directionality is very important to determine whether we times or divide. So we end up with $15 divided by 80%. And that gives us x is, hold on here, 15 divided by 0.8. It gives us $18.75 as the original price. Okay, so that this represents the original price. So Harry receives a raise of $1.50 per hour. This was 6% raise over his previous salary. So I'm going to write my percentage ratio. And I have to determine, is the $1.50 the part or the whole? So $1.50 is the raise. That is the 6% portion. So 1.5. And we are looking for the whole. So the 100%. So his original salary is what we're looking for. My decimal multiplier is my decimal percentage. Notice again the directionality. This is multiplying this way, so I must do the opposite. Divide in the opposite direction. So I have 1.5 divided by 0.06. And that gives me $25 as my original amount. So that is my original or previous salary. Now, if we wanted to find out the salary now, after the $1.50, we can just add that on, and that's going to be $26.50 is his current salary. Now I'm just going to do a separate problem over here, which is maybe we could ask what is the current salary. Now we could have done it in parts. We could have added on. So this is a separate question. It's related to the first one. Now we could have added on. We can add on the $1.50 to the $25, but we could also set it up this way. We know the 6%. But we're trying to figure out, not the 100%, but we're trying to figure out the 106% amount. And $1.50 represents the 6%. And here, I'm going to call this A. A represents the current amount. I'll just maybe say C. We'll call that the current salary is going to be 106% of the previous salary. So if without knowing what the previous salary was, I can just find out directly through times and divide without adding on. Again, we don't, in this case, we're avoiding the mixing addition and multiplication. So it makes our calculations much easier and the algebra easier. I can just use a times and divide here to work out the C value. So working out my multiplier, in this case, I'm just going to use, I'm not going to use my decimal multiplier. I'm just going to do this. I'm going to find my multiplier going from top to bottom. So 106 divided by 6 gives me this decimal multiplier of times 17.6 repeating. 6 repeating. Okay? And I'm going to use that same multiplier, so it's times 17.6 repeating that multiplier. And I'm not going to round it, I'm just going to use it on my calculator. I'm going to go times 1.5, and that's going to give me C directly without having to add on. I've been able to just keep the times and divide math to get the answer of $26.5, or $26.50. And we can do this ratio of comparison with any decimals. It doesn't have to always be with 100%. We can actually do this times divide multiplying relationship with percentages other than 100%. So that is possible. When we compare percentages, percentages can be compared as a ratio, and if this can be compared as a ratio, we can use multiplication math to solve these types of problems.